is Fahmi Al-Rifat. In this video, I will discuss about cross-site request forgery attack and also demonstrate the attack in the seedlet environment. This is a common attack that tricks a web browser into executing an unwanted action in an application to which user is logging. Normally, this is done by inducing the user by allowing him to click a link which induces malicious request that the attacker wants to perform. The reason to consider CSRF as a highly dangerous because just by a one click, something that user never wanted to be happen that can be performed. In the above scenario, a attacker shared a link which is contain malicious site and victim opened the link in the browser. Browser load malicious payload from maliciousite.com, and in the last step, browser send request including user credential in the target site.com, and which request is accepted and processed as a legit user request. Very common example of CSRF attack is stealing money from the user who perform online transaction. Keep in mind that there are many other things that thieves or this case hacker steal from the user. Well, a successfully performed CSRF can do big impact like damage client relationship, data theft, change the credential and restricted access, unauthorized funds transaction. About how CSRF is performed. In the most of the cases, CSRF attack were performed using malicious social engineering. It may be an email, link or any other thing which gets the user attention, such as offer or giveaway sort of thing. Clicking the email or the link will allow the malicious URL to execute and perform its tasks. Normally, before performing a CSRF attack, the attacker exploits how the target web application deals with authentication. In order to perform CSRF successfully, the victim must be authenticated in the target site. Typically, the attacker studies application behavior and tries to make the forged request to look like as legitimate as possible. In the above example, attacker forges a request for a fund transfer where visitor clicks a link which sends a request to the targeted website. Website validates request and transfers the fund from the visitor account. Synchronization token and the double submit cookies are the well-known prevention measures. Now I will demonstrate the seedlet task of CSRF attacks. First of all, we have to set lab environment. Here DC build and DC up is command for Docker. Here we use Docker build to compose our Docker container and DC up command to run the container. Next we will do DNA configuration for our web servers. Here seed server is our social media site and akakar32.com is our malicious website. These are the username and password of our seed server website. Our first task is observing HTTP request with HTTP header live. Let's do this. Here we are filling the login form with proper data, and before submitting the button, we open the HTTP live header to view the request. The second request is our desired HTTP request for login. This is a post request. We can see the username and password in the backward of the request. This is how our task 1 is completed. Task 2 is demonstrating CSRF attack using GET-REQUEST. Let's consider a case where Sami wanted to become friend to Alice, but Alice refused to do that. Sami decided to use CSRF attack to achieve his goal. Here attacker.com is malicious site which will be used by Sami. Let's demonstrate how we can do the task. We log in Sami's account and see in the Sami had no friend. We search Alice and try to make a friend request. Before clicking add friend button, we open the HTTP header live. Collect information about the HTTP request. Let's click the request and we see this is a GET request. This part of URL we have to consider about. Let's copy this part and paste this path in our add friend HTML. We are making this HTML such that if Alice click this HTML, Alice auto becomes Sami's friend without knowing. To perform this, we are using HTML image tag. In image tag of HTML, image is called from source. Instead of image, we are giving our copied HTTP GET request. To complete our GET request, we need Sami's GID. Let's inspect the source code and find where the Sami's GID is. Our target is anyone who click the link will be Sami's friend. So we need Sami's GID. Find the Sammy's GUID in the bottom of the source page. Here we find the Sammy's GUID bingo. It is 59. Let's paste this in our malicious code. Second thing to notice, we are keeping height and width of the image 1 and 1. It's because victim cannot see the image, thus cannot suspect the attacker. Now it's showtime. Let's log in from Alice. Here we can see that Alice has no friend. Now when Alice will visit attacker.com, which is malicious site, and click add friend attack, our attack will be launched. Let's see Alice friend list now. Bingo, Sammy is added. Because attacker.com sent friend request to Sammy with cross-site Alice cookie. 3. We will do another CSRF attack with post request. Sammy, after adding himself Alice friend list, Sammy wanted to do more. He wanted Alice to say Sammy is my hero with cross-site forgery attack. Now let's demonstrate the task. For this we have to log in as Sammy. Now attacker Sammy will check edit profile to know how a edit profile request constructed after giving a proper data. And right here, Sammy is my hero. In the save button, open HTTP header live. The second request of the HTTP header live is our desired request. To know the proper format, we have to click this request. Here we see it's a post request. In below we can see how the request is constructed, concatenating with proper field. Then we have to observe the brief description field, how it's constructed, and its GUID. When we click the save button, is Sammy's GUID. Find Alice's GUID. Before going that part, let's write our malicious code. The JavaScript code will construct the same post request. We have to give our URL, and p.submit will auto submit the URL. And we set our request with post method. Sammy have to change the button action URL with the seed server URL. And he have to construct proper post method field. We can find proper format here. Instead of Sammy, we have to give Alice name because Alice is our victim here. Then we have to find the other proper format of the field. Let's find brief description. Here it is. Description field, we have to write Sammy is my hero. Now we have to find the GUID field. Here it is. Instead of Sammy's GUID, we have to give Alice's GUID because when Alice will click the link, Alice's profile will be edited and her bio will be Sammy is my hero. It's showtime. Let's log in from victim Alice. Here in Alice's profile, we can see Alice have no bio. Now Alice click the malicious site and let's check the profile again. Alice's bio is changed to Sammy is my hero and attack successful. That's how we do our task 3. Now we will answer the extra questions. In the first question, let's consider a scenario where Bobby wanted to attack Alice, but Bobby don't know the Alice password. So is it possible for Bobby to get Alice's GUID? The answer is yes, it is possible. We will demonstrate how Bobby can get Alice's GUID. Now let's log in from Bobby's ID. In the Bobby's profile, inspecting source code, Bobby can get his GUID. But we need Alice's GUID. How we can get it? GUID is in the end of the source code. This is Bobby's GUID, Bobby's name and Bobby's GUID. We need to inspect Alice's page to know the Alice's GUID. To get Alice's GUID, Bobby have to search Alice's profile. In this case, Bobby don't have to be Alice's friend. Let's inspect the Alice profile. In the end of the page, we can find Alice's GUID. Let's find. Here ally's name, and here is the ally's GUID. And this is how Bobby can know the ally's GUID without knowing ally's password. Next, move forward to our next question. Our second question is if Bobby would like to launch attack anybody who visit his malicious web page in case he doesn't know who is visiting the page. Still launch the CSRF attack and modify the else page? Answer is no if Bobby hardcode the victim's GID. Because edit profile requests need victim's GID. On the other hand, if Bobby used JavaScript to get victim GID and use as a variable, then the answer is yes, because Bobby needs victim's GID which will be dynamically known by JavaScript variable. For this purpose, we have to know the seed's website JavaScript variable. Our task force is defend the CSRF, and initially most applications put a secret token in their page. The website also have these countermeasures. Before purpose is intentionally disabled. More recently, most browsers implemented this method. Discuss how this defense mechanism works. This defense mechanism, we need two extra fields. One is token and one is TS. This token mechanism is needed to defend the cross-site request. The website will have its own token. In the else website, TS is the current time value and we generate token from the TS. Token is unique for the else website. For malicious website, the session token will not be matched. So browser will not send this to cross-site forgery request. To enable the token validation in the seed website, we have to comment out the return in the second line of validate function. After doing so, our token mechanism will work perfectly and no cross-site request can be done. Let's demonstrate. After going to the proper source code destination, we open our desired file and make the proper change. Let's find our validation function here. Here it is. Let's comment out the return part. After commenting out, the function will work properly. Our work here is done. Let's check, does cross-site forgery attack can be done as before or our defense mechanism works successfully. Let's try to do the same attack as before. To perform the same attack, we log in again as victim allies. We have to remove the semi to perform our attack again. Now we remove the semi is my hero and save to make the thing as before. In the allies profile there is no bio and no friend semi, and now allies visit the malicious website and let's check what happened. We can see allies login in malicious site and semi become friend. That means our defense mechanism failed. Maybe we didn't change the validate function properly, we have to comment out the return function. Let's again do that. Yes, there is a mistake. We done again, and let's check again. First of all, we have to remove semi, and when allies go to the attacker page, and we see no token, and token is missing, and semi cannot be friend. After checking add friend, we also check edit bio, and this time also token is missing. That's how we prevent CSRF attack. Finally, allies is safe from security and privacy violation. This all about today. Thanks for having patience.